in this video, we are going to be talking about first order differential equations. There are two ways in solving the first order differential equation. We have the method of separation of variables and then the integration factor method. But in this video, we'll be talking about the method of separation of variables. So let's assume we are given a differential equation, which is dy dx equals the product of g of x and then h of y. Now, the method of separation is we need to take all the variables that are, for example, in this case, you see that x is the independent variable and then y is the dependent variable. We need to make sure that all the functions that are dependent on the dependent variable is on one side, and all the functions that are dependent on the independent variable is also on the other side. So in this case, what we can do is that we can divide through by h of y. So you can say 1 over h of y dy dx is equal to g of x. Then another thing is that you see here's dx, here's x, so we can multiply through by dx. So it becomes 1 over h of y dy equals g of x dx. So now we can go ahead and then integrate. So we can integrate 1 over h of y dy, then that is equal to the integral of g of x dx. Now let's let p of y to be equal to 1 over h of y. So it means that this integral becomes integral of p of y dy, and that is equal to integral of g of x dx. So anytime we are given a first order differential equation and we are able to separate it into this form, then this is what is called the method of separation of variables. So let's take some examples. Solve into brackets 1 plus x dy minus y dx. So the equation is into brackets 1 plus x dy and then minus y dx. This is equal to 0. So we can take y dx to the right hand side. So it becomes 1 plus x dy equals y dx. So you see that here is 1 plus x, here is the y. So we can divide through by y. So 1 plus x dy divided by y is equal to dx. Then in this case we can divide through by 1 plus x. So here becomes 1 over y dy equals 1 over 1 plus x dx. Now, having gotten the equation in this form, we'll be able to separate the variables. So at this point, we can go ahead and then integrate. So it becomes integral of 1 over y dy equals 1 over 1 plus x, integral of that dx. So if you integrate 1 over y dy, you are going to get natural log of y. And this is equal to, now, you see that when we differentiate 1 plus x, we will get 1. So this is also equal to natural log of the absolute value of 1 plus x. So let me bring absolute value here. And plus the constant of integration, which is c. So we have natural log of the absolute value of y equals natural log of the absolute value of 1 plus x plus c. Now, you see that y can be equal to exponent natural log of the absolute value of 1 plus x then plus c. This can also be rewritten as exponent c then times not exponent natural log of into bracket 1 plus x. So now we want to represent exponent c as a big constant, capital K. And then now anytime you have exponent natural log of a function, let's say x, it's equal to the function itself, which is x. So y is equal to k then times 1 plus x. Solve the equation dy dx is equal to 1 plus x plus y plus xy. So what we'll do in this case is that we need to first factorize. You see that there is x here and there's x here, so we need to group that. And then there is 1 plus y here, so we need to also take that to one side. So dy dx is equal to 1 plus x, and then plus, let's factorize y out, y times 1 plus x. So dy dx is equal to, you see there is 1 plus x and there's 1 plus x here, so we can further factorize that. So this becomes 1 plus x. Then let's open a bracket. Here is left with 1 plus y. So what we can do is that, you see that here is the y, here is 1 plus y, here is 1 plus x, and here is dx. So we can divide through by 1 plus y. So 1 divided by 1 plus y dy is equal to, then let's multiply through by dx, 1 plus x dx. So we can go ahead and then integrate. So integral of 1 divided by 1 plus y dy is equal to integral of, into bracket, 1 plus x dx. So now if you differentiate 1 plus y, it's equal to 1, and that is what we have in the numerator. So this becomes natural log of the absolute value of 1 plus y equals, if you integrate 1 is x, and if you integrate x is 1 over 2x squared, and plus the constant of integration c. So solve dy dx equals, into bracket, 1 plus y squared, then times all of that times x squared. So this one too, we can divide through by 1 plus y squared. So it becomes 1 divided by 1 plus y squared. Sorry, let me rewrite it. 1 divided by 1 plus y squared. Then dy equals, then let's multiply through by dx. So it becomes x squared dx. So we can go ahead and integrate. Integral of 1 divided by 1 plus y squared dy is equal to integral of x squared. Sorry, I made a mistake here. Here is the x, because we multiply through by the x. So here's the x. Now, integral of 1 over 1 plus a squared, all of this dA is equal to tan inverse of a. So integral of 1 divided by 1 plus y squared is equal to tan inverse of y equals, if you integrate x cubed, you are going to, sorry, if you integrate x squared, you are going to get 1 over 3 x cubed plus the constant of integration c. Now we can go ahead, and now if you have tan inverse of a to be equal to b, then it implies that a is equal to tan b. Therefore tan inverse of y becomes y equals tan of, into bracket, 1 over 3 x cubed plus c. We are supposed to solve for y, which is, into bracket, 1 plus y squared times y prime equals exponent xy. So what we can do is that, let's rewrite this as 1 plus y squared, into bracket, then y prime is the same as dy dx equals exponent xy. Then now we can divide through by y. So this becomes 1 plus y squared divided by y, then dy dx equals exponent x. So let's multiply through by dx. So this becomes 1 plus y squared divided by y dy equals exponent x dx. So we can go ahead and then do the integration. So integral of 1 plus y squared divided by y dy is equal to integral of exponent x dx. So if 1 divided by y is the same as, so let's break this integral into 2. So this integral becomes integral of 1 over y dy, then plus integral of y squared divided by y dy equals integral of exponent x dx. This further becomes integral of 1 over y dy, then plus y squared divided by y is the same as integral of y dy equals integral of exponent x dx. Now, if you integrate 1 over y, you get natural log of the absolute value of y. Then plus, if you integrate y, it is half of y squared. And that is equal to, if you integrate exponent x, you get exponent x. So this becomes exponent x plus the constant of integration c. Find the general solution of the equation x cubed dy dx equals into bracket 1 plus x squared times y. Given that, so these are boundary conditions, y of pi over 2, y is equal to pi over 2 when x is equal to 1. So the equation is x cubed, then dy dx equals 1 plus x squared tan y. So let's divide through by tan y. This becomes x cubed divided by tan y, and dy dx is equal to 1 plus x squared. Now, let's divide through by x cubed. So you are left with 1 over tan y dy dx is equal to 1 plus x squared divided by x cubed. So let's multiply through by dx. We'll get 1 over tan y dy is equal to 1 plus x squared divided by x cubed, then dx. So what we will do is that now 1 over tan y, let's rewrite this here. So 1 over tan y is the same as sin y over cos y. 1 over tan y becomes cos y. So integral of cos y divided by sin y dy is equal to, now 1 divided by x cubed is the same as x exponent minus 3 into bracket. So integral of that, and plus x squared divided by x cubed is x exponent minus 1 dx. Now, how do we integrate this? You see that when we differentiate sin y, we will get cos y. So it implies that this becomes, the integral of that becomes natural log of the absolute value of sin y equals, now if you integrate x exponent minus 3, it becomes minus 1 over 2, then x exponent minus 2, then plus, if you integrate x exponent minus 1, you are going to get natural log of the absolute value of x plus the constant of integration c. Now, I have already shown how to do this kind of integrations. I will link the video in the description. So now let's proceed. So let's rewrite this. So this becomes natural log of the absolute value of sin y equals, let's write natural log of the absolute value of x first. Then now minus, here becomes 1 over 2x squared, then plus the constant of integration c. However, we're given boundary conditions, that is y of pi on 2 is equal to 1. So let's find y of pi on 2. That means wherever we see y, we should replace it by pi on 2. And wherever we see x, we should replace it with 1. So here becomes natural log of sine pi on 2. Then that is equal to natural log of 1 minus 1 over 2 times 1 squared plus c. Now, natural log of 1 is 0. So here is 0. Then sine pi on 2 is the same as sine 90. Sine 90 is 1, and natural log of 1 is equal to 0. So here 2 is also 0. Then minus 1 squared is 1. 1 times 2 is 2. So here becomes 1 over 2 plus c. So this implies that c is equal to 1 over 2. And therefore, we can then put it in the equation. And if we put it in the equation, we find out that the true solution becomes natural log of the absolute value of sine y is equal to natural log of the absolute value of x minus 1 over 2x squared plus 1 over 2. So this is the final answer.